Now we're going to look at what I sort of call reduction and increase type problems. Something's going to reduce, and when it does, it turns right around and something else increases. So the first problem we're going to look at is problem 18. A university student center sells 1,600 cups of coffee per day at a price of $2.40. A market survey shows that for every 5-cent reduction in price, 50 more cups of coffee will be sold. Okay. How much should the student center charge for a cup of coffee in order to maximize their revenue? So for me to figure out revenue, remember we're going to multiply number of cups times price. But then I have to take into consideration this reduction and this increase. So first thing I'm going to do is I'm going to indicate what I'm going to consider x to be, and I'm going to let it be the number of reductions. But before I come up with an equation, let's see if we can figure out a pattern here to help us get to the equation. So I'm going to have a table, and if I multiply cups times price of the coffee, then I will get my revenue, like I said a few minutes ago. So the initial one they gave me was $1,600 and at a price of $2.40. Now, if I can reduce this by a nickel, then my number of cups of coffee goes up by 50. So let's see if I reduced it by a nickel, and it goes up to, I add 50 more cups of coffee. Do not combine these yet. I need you to see if you see a pattern. So the next one, let's go down another nickel, and my cups go up by 50. See how many times I did this. I went down another nickel, and my cups went up, so this goes on and on and on. So if my number of reductions is x, see if you see this. I could go 2.40 minus 0.05x. This one I could do 1,600 plus 50x. So let's see if I've done that. Okay. So now the reason I had to go and do this is I had to find an equation to get me revenue. So if I do the 1,600 plus 50x times the 2.40 minus 0.05x, I'll be able to come up with a formula for revenue. FOIL this out. Let's see, I think I did. Combine like terms. Another parabola concave down, so what we'll come up with is going to be our maximum value. So I took the derivative, let's see, and like before I've set it equal to 0. So it looks like x needs to be 8. Now you stop in here, you haven't finished the problem. You need to circle back and finish. It says how much should the student center charge for a cup of coffee in order to maximize their revenue? They need 8 reductions. They want to know about the charge, so I would put 8 right here. So you might do that. Well, see, actually we could. 8 times a nickel would be 40 cents, so it looks like if they charge $2, it says University Student Center should apply 8 reductions to maximize their revenue, sell coffee for $2. It doesn't ask for this. All they asked for was how much should they sell it for. But if they had asked what the maximum revenue would be, it would be $4,000 per day. Okay? Let's see another problem. Now we have cups of coffee up here. In problem 22, I've got a commercial pear grower. Must decide on the optimum time to have fruit picked and sold. If the pears are picked now, they will bring 30 cents per pound, with each tree yielding an average of 60 pounds of saleable pears. If the average yield per tree increases 6 pounds per tree per week for the next 4 weeks, but the price drops 2 cents per pound per week, when should the pears be picked to realize the maximum return per tree? What is the maximum return? So it says when should the pears be picked, so I'm looking at weeks. So I'm going to let x be my number of weeks, and let's see if I can start another table like I had a few minutes ago. Now, Pears are picked now, they'll bring 30 cents per pound. If we wait, price drops 2 cents. Right now, the tree averages 60 pounds of saleable pears. If we wait, it increases by 6 pounds. So there's a reduction and an increase. So let me start off with pounds and cents per pound. So the initial part they gave me was 60 pounds right now. It's going to bring 30 cents per pound. If I wait a week, poundage goes up, price goes down. And if you see, if you see a pattern here, I would have 60 plus 6x, and over here I'd have 0.30 minus 0.02x. So let's see if that's what I've got. Okay, so my revenue would be that times that. FOIL it out, simplify. Parabola concave down, we're going to be finding the maximum. Go get our derivative. Sounds familiar. Next thing, set it equal to 0. Now remember what I let x be. I let x be number of weeks. So it looks like, when should the pears be picked? It looks like it need to be picked in about 2.5 weeks. For a maximum return, well, for me to find that out, you're going to have to take your 2.5 back to your revenue function and see if you come up with that. So this is the reduction and increase type problems. So probably problems 19, somewhere in there. See if you can see these and see if you can see the pattern and try those problems. Talk to you later. Bye-bye.